Because if you have any technical question about farming, if any farmer calls cooperative affairs and cooperative affairs department doesn't know the answer, they always call Jeroen. And he sits a 1.5 hour with the farmer to talk and to explain carbon footprinting. So I will now invite you to the stage, Jeroen Hospers, to present how dairy farms developed between 1990 and 2019.
Yes. Well, that's what I'm going to do. So we saw let's also stay visible for the people online. We saw, of course, the results now, but you also wonder what part is coming from, let's say, the farms changing. And that is actually what I'm going to tell a bit about. So the average Dutch farm, how did it develop since 1990? In terms of farm size, the herd, milk production and agricultural practice and some other things. Well, to start off with farm size first. Well, what you see here is the hectares per farm for grassland and for maize land. Well, 21 hectares, around 21 hectares in 1990 to 2.5 that size in 2019, with almost remaining share of grassland. So 80% is grassland. That is, over time staying a stable fraction. Then towards the herd, that also grew. Also almost 2.5 times as much cows. So this is dairy cows per farm, so from 40 to 79 per farm. What's good to mention also on the previous slide is that, this is of course rising, but the number of dairy farms is 1/3 of that in 1990, roughly in 2019. And so that's good to take into account. But there's more than dairy cows, of course, at farms, because there's also young stock. And this is the same figure, but then also topped with the young stock categories in green and red. And then you see that these are also rising, and you also see something strange. I think in 2016, anybody in the audience that has an idea on why this happened? No, Cora is the. Yes, indeed. So what happened here is phosphate rise. That was the comment from the audience. And that's exactly the case. So what happened there is that the total amount of phosphate you were allowed to excrete on your farm was limited. And farmers in response replaced young stock for dairy cows to be able to produce more milk still. So that is what you see. And if you then add this line, which is the young stock number, that is the number of young stock per 10 dairy cows, you see this actually declining from the introduction of the phosphate rise system. So this is a, let's say, policy-induced change at farms. Then, of course, this is also what a lot of people also want to know, what happened to milk production. In red, it's milk production per cow. So, and then in FPCM, so fat and protein corrected milk. So from, let's say, 6,300 to 9,400 in this time window. And in blue, you see the total delivery of milk, which is a steeper line. And then you might wonder, why is it steeper? Because also the number of cows, of course, which you already saw, increased. So it's quite a dramatic increase of milk production per farm. Due to these two facts: more milk per cow, more cows per farm. Then, then we also have to say something about intensity. So in red, it's the intensity per hectare. So how much fat and protein corrected milk was produced per hectare of farm. Yeah, we see this increasing. So that is what already was also introduced by Pablo. But another development in terms of specialization, is also the share of meat versus milk, because as a dairy farm you produce, of course, milk, but also you sell live animals, either for slaughter or as replacement cattle. And what you see there is that that is declining. So the ratio between milk and meat sold is declining. So more milk versus meat. And that is because replacement is going down, so cows getting older and producing more milk still, versus 1990. So there's a very much specialization towards milk production. Not the dual purpose cow like in 1990. Then, of course, this milk production also didn't came from the air. That is what we know from science. So this is what you see here is the total dry matter intake of a dairy cow over the years, also divided into the different component of this of the ration. So, and then if you see from the bottom upwards, it's the blue first, that is fresh grass. Well, Pablo already introduced that the share of manure in excretion in the pasture was lower. Well, that's also what you see here. So cows ate less fresh grass in the pasture because they spent less time outdoors. That was actually more or less exchanged by more grass silage. So the total share in the ration of grass is rather stable over the years, but there was exchange of fresh grass and grass silage. And then in green, a little bit of a rise in maize in the ration. And then byproducts, yeah, was also a limited share, the purple one. And then the top two ones, the blue and the orange, are compound feed. And then in two types, so low and high in protein. And there you see also a shift in the more recent years. So more protein-rich compound feed, probably to keep up also with the production after phosphate rise. And then the line on top, that is the milk production, the same as we saw before. But what you see is that it doesn't follow the, let's say, the dry matter intake line. So what does this mean? Feed efficiency also produced. So more milk per kilogram of dry matter intake. So feed efficiency improves. Then towards the other topic that was also already a bit in the results part. This is of course also kind of quite a change. So this is about how much nitrogen did farmers apply on their land. Well, as was already introduced, it started off with around 600 in 1990. To half of it in 2019. So this is quite something, let's say, reduction. Most of it in artificial fertilizer, but also a bit in manure. And then still keeping up the production. So what you see here is the production per hectare for grassland and for maize silage. For maize, it's even increased. And for grass, it stayed the same. While, of course, the application rate went down. So this is quite, in terms of efficiency, a thing. Less manure, keeping up, or for maize, even higher production. So that is something that was, let's say, the good agricultural practice. And then nitrogen excretion, quite a hot topic, of course, these days. Not so much of a change in total, yeah, of course, a bit, as you can see. So this is the stacked bars in blue and green. And then green is again in the meadow, which I already explained why that is less in the most recent years. And then blue in the stable. But then if you also express it, the nitrogen excretion per kilogram of fat and protein corrected milk, you see it going down. So what this holds is that the nitrogen, or let's say the protein that goes into the cow, is better used by the cow to produce milk. And that is, of course, quite an accomplishment from, well, let's say 23 to 15. So this is feed efficiency, but also nitrogen efficiency or protein efficiency by the cow that is increasing. And then I think this is the last one before the conclusions. Of course, also something on energy. Here you see a line in green for electricity use per ton of fat and protein corrected milk produced, and the same in blue for diesel use. And there you see also efficiency gains. So less energy used, and they follow a similar trend, less energy used per ton of milk. Well, then towards the conclusions. So what you see is that the dairy farms, of course, increased in size in milk production, and they further specialized towards really milk production. They adjusted to policy developments. which I think will also happen in the future. And all of this led to higher efficiencies. But the question, of course, is, and that will also be addressed later on, will this continue? So can we expect this efficiency to continue? And is that enough to contribute to climate goals? Is this enough, or do we have to speed up, or might we even need another thing, maybe a system change, and not, let's say, the incremental change that we saw over this series? That is, I think, a big question for the future.